Atomic structure and notation. In this lesson, we're talking about atoms and subatomic particles, specifically protons, neutrons, and electrons, atomic number, atomic mass, isotopes, calculating average atomic mass, periodic table notation, and chemical symbols. Atoms. Atoms are the building blocks of all matter. An atom is made up of smaller bits called subatomic particles, which include protons, electrons, and neutrons. Protons are positively charged. They're located inside the nucleus, and they have a relative mass of 1. Electrons are negatively charged. They're located outside the nucleus, and they have a relative mass of 0. That doesn't mean that their mass is 0, it just means that compared to protons, their mass is so small that we don't count it. And then we have neutrons, which are neutrally charged. They're located inside the nucleus, and they also have a relative mass of 1. Structure of the atom, nucleus. The nucleus is where the protons with a positive charge and the neutrons reside. Protons were the first ones discovered. Later evidence showed the existence of a neutral particle, no charge, which was later called the neutron. So our nucleus is going to be represented by this whole area that surrounds both the red and the blue particles. Structure of the atom, proton. Protons, the blue ones, have a positive charge. They're found inside the nucleus. They have a relative mass of 1, and they determine what is called the atomic number. Structure of the atom, neutron. Neutrons, the red, have 0 charge. They're neutrally charged. They're also located inside the nucleus. They also have a relative mass of 1, but they determine what's called the isotope. Isotopes are 2 of the same element with different masses, and I'll talk more about isotopes in a moment. Structure of the atom, electron. Electrons, the gray ones, have a negative charge. They're found orbiting outside the nucleus. They have a relative mass of 0, and they determine the ion. Atomic number. Each element is different because they contain a different number of protons. If the number of protons was the same, then the atom would be the same. The atomic number of an element is the number of protons in the nucleus. In an uncharged atom, the number of protons equals the number of electrons. The key, though, is uncharged atom. We can have things like ions, which are going to have different number of protons and electrons, but in an uncharged neutral atom, number of protons equals the number of electrons. So what I'd like you to do now is pause the video, find a periodic table, and then confirm the following atomic numbers on the periodic table. So find carbon, and verify that you can see that the atomic number is 6, and this would mean that there are 6 protons. For phosphorus, find that there's an atomic number of 15, and make sure that gold's atomic number is 79. Make sure you can use your periodic table to find the atomic number. So pause the video now and give that a try. Atomic mass. Atomic mass, otherwise known as mass number, is the number of protons and neutrons inside the nucleus of an atom. The atomic mass is going to equal to the number of protons and the number of neutrons. We're going to add them together. So for instance, oxygen 16. This 16 here represents the mass. So this is oxygen with a mass of 16. It has 8 protons, 8 neutrons, and 8 electrons, as we said in a neutral atom, which this is. It has the same number of electrons and protons. Therefore, it has an overall mass of 16. Arsenic, with a mass of 75, is going to be a little bit different. The atomic number of arsenic is 33. So we find that on our periodic table. So to find the number of neutrons, we're going to take the mass, which is 75, and we're going to subtract 33. When you take 33 away from 75, you find out that it has 42 neutrons. If it has 33 protons, it's going to have 33 electrons, and then its mass number, as we can see, is right here, 75. Phosphorus, with atomic mass of 31, has an atomic number of 15, so it has 15 protons. It has 16 neutrons, because 31 minus 15 equals 16. It has 15 electrons, because the number of electrons equals the number of protons, and then the mass that we just talked about is 31. So you need to be able to look at your periodic table and determine number of protons, neutrons, and electrons based on the information given. Atomic mass. So if you recall, protons and neutrons each have a relative mass of 1. So for instance, if you have an atom with 3 protons and 4 neutrons, the average atomic mass will be 7. However, when you look at the periodic table, you'll notice that the masses aren't whole numbers. So beryllium, 9.0122, oxygen, 15.999. How could that be? Well, if you recall also, isotopes are the same element with a different number of neutrons. We talked about that in the previous slide. Oxygen has 3 main isotopes, oxygen 16, oxygen 17, and oxygen 18. Keeping in mind the 16, 17, 18 represents the mass. Oxygen 16 has 8 protons, 8 neutrons, and its abundance is 99.76%. So in nature, you are most likely going to find oxygen 16. You're going to find it 99.76% of the time. However, you'll also find these other isotopes. You'll find oxygen 17, which has 8 protons, 9 neutrons, but its abundance is only 0.04%. And then you'll have oxygen 18, which has 8 protons, 10 neutrons, and its abundance is 0.2%. So it's going to be much more likely to find the oxygen 16 than the other two. The average atomic mass of oxygen is calculated by taking the weighted averages of the isotopes. This is why the atomic mass listed isn't a whole number. So how do we find the weighted average of the isotopes? Well, let's calculate the average atomic mass of the following hypothetical element. Example with a mass of 4, 5, and 6. So you can see how we have it written. The thing that stays constant is, of course, the number of protons. There's going to be 2 protons, 2 and 2, but the number of neutrons changes. And you can see we have our abundances right here. So the most abundant is going to be the EX4. So you know our final answer is going to be pretty close to EX4 because it's the most abundant. But the other ones will take some of that abundance away as well. To find the average atomic mass, we're going to multiply the mass by its abundance. So do this for each mass and then add them together. So for instance, the mass of 4 times 0.5, which is 50%, is equal to 2. Then we're going to have 5, we're going to multiply that by 0.4, and that's going to equal 2 as well. And then we're going to take 6 and we're going to multiply it by 0.1, and that's going to equal to 0.6. Now we're going to add them together. 2 plus 2 is 4, plus 0.6 is 4.6. So the weighted average for this particular isotope would be 4.6. Now we said it would be close to 4 because its most abundant is 4. However, there is still a pretty good percentage that's at a mass of 6. Therefore, that's going to bring it closer to that 6, but not as close as it is to the 4 because the 4 is the most abundant. Periodic table notation. The periodic table notation is going to contain the symbol of the element, the mass number, and the atomic number. So you can see up here in the superscript is going to be the atomic number, the subscript is going to be the mass number, and right in the middle is going to be the symbol. So for example, for oxygen, the atomic number is up top, it's 8. The symbol is O, and the average atomic mass is 15.999, and that's located below the symbol. So what is a chemical symbol? The chemical symbol tells us what atom it is. It's a short form, sometimes English, sometimes Latin. So for instance, C is short form for carbon, whereas PB is going to be the symbol for lead because it's the short form for plumbum, which is going to be the Latin version of lead. It always starts with a capital letter and is sometimes followed by one or more lowercase letters. So you can see BE is capital B, lowercase e, whereas oxygen is just an uppercase O. So example, again, oxygen is just an O, nitrogen is an N, and sodium is an A. You got to keep in mind, though, that C little o is cobalt, whereas big C big O is carbon monoxide, two different atoms put together. So you got to keep in mind that if you have a lowercase, that signifies the same element, but if you have another uppercase, then it's going to signify a different element. So how are protons, neutrons, and electrons related? Well, the atomic number, remember, is the number of protons. The number of protons equals the number of electrons in a neutral atom. The number of protons plus the number of neutrons equals the atomic mass. And keeping in mind, when we're figuring this out, we need to round the atomic mass to the nearest whole number. And then we can use these other two formulas, number of neutrons equals atomic mass minus number of protons, to figure out the neutrons, and we can figure out protons by subtracting the number of neutrons from the atomic mass. So that's just using this formula here and changing it around to solve for the other two variables. So how many protons, neutrons, and electrons are found in an atom of beryllium? The atomic number is the number of protons, which you can see is 4. We know that the mass number is going to equal to the sum of the protons and neutrons. Therefore, the number of neutrons is going to equal to the mass minus the number of protons. We're going to round our mass number from 9.0122 down to 9. And we're going to take 9 minus 4. Number 4 was the number of protons. And we're going to find the number of neutrons is going to equal to 5. Check your understanding. So pause the video and figure out the number of protons, electrons, and neutrons for oxygen. Well, we know the number of protons can equal the atomic number. So that's going to be 8. We can see the atomic numbers right there. The number of electrons is going to equal the number of protons in this neutral atom, so we're going to say 8. The number of electrons is going to equal the number of protons in this stable atom, so we're going to say 8. And then the number of neutrons is going to equal to the mass minus the number of protons, and that's going to be 16, rounded up from 15.99, minus 8, and that equals to 8. Check your understanding. Pause the video and find out the number of protons, electrons, and neutrons for lithium. The number of protons is going to equal the atomic number, which is 3. The number of electrons is going to equal the number of proton, which is 3. And the number of neutrons is going to equal to the mass, which rounded up is going to be 7. We round it up because 6.9 rounds up to 7. Minus 3 equals 4. So that's lithium. Now these are a little bit harder. An element has an atomic number of 34 and an atomic mass of 79. What is the number of protons, neutrons, electrons, and then the complete symbol? So pause the video and answer these 4 questions. Now the number of protons is going to equal the atomic number, which is going to equal to 34. The number of neutrons is going to equal to the mass minus the number of protons, which is going to equal to 79 minus 34, which is equal to 45. The number of electrons is going to equal the number of protons, which is going to be 34. And then the complete symbol is going to be Se, because when we find the atomic number 34 on the periodic table, we find the symbol Se. The mass is going to be below. The mass is 79. And the atomic number is going to be up top, and that's going to be 34. And there's our complete symbol. Check your understanding. If an element has an atomic number of 91 and contains 140 neutrons, what is the number of protons, number of neutrons, number of electrons, and the complete symbol? So pause the video and answer this question. The number of protons is going to equal the atomic number, which is 91. The number of neutrons, we're told, is 140. The number of electrons is going to equal the number of protons, which is 91. And the complete symbol is going to be the symbol in the middle, which we have to look up on the periodic table. And when we look up the atomic number 91 on the periodic table, we find the symbol that corresponds is Pa. We're going to put the mass below. Now the mass is going to equal to the protons plus neutrons. So we have 91 plus 140, which equals 231. So we write 231 below, and then we write the atomic number above, which is 91. And then we're done. And that concludes our lesson on atomic structure and notation.